Hello everyone, welcome to Chemical Bonding YouTube channel. Today we will discuss on questions that is very most conceptual questions. According to me, it was the most conceptual question asked ever. So this question was asked in GATE 2020. So this is from carbohydrate chemistry. So the question is was like that: when we treated with alpha D glucose with excess acetone, then what will be the product? So before discussing the questions, so I want to give you some basic knowledge about glucose and their cyclic form. So glucose, their anomeric form and their cyclic form and their percentage composition in equilibrium. So let's see. So this is the structure of D-glucose. So this is acyclic structure, and these are the cyclic structure of D-glucose. These are called anomeric structure. So D-glucose means, so first we all know that the naturally occurring carbohydrate. So glucose is carbohydrate. It is a aldohexose. Fructose is also a carbohydrate. It is called aldoketose. So aldohexose and aldoketose are carbohydrates. So naturally occurring carbohydrates means in nature, the carbohydrate we get from nature. These are D in nature. D in nature means this the bottommost chiral carbon. So this there are 1 2 3 4 chiral carbon. The bottommost chiral carbon, if there is present, if the OH is present in bottommost chiral carbon is right side, then it is called D-glucose. So now this glucose exists in more than 99% in cyclic form. It exists in acyclic form about only 0.02%. About only 0.02%. In cyclic form, there are two types of cyclic form. One is called as alpha D glucopyranose, beta D glucopyranose, and other cyclic form is alpha D glucofuranose and beta D glucofuranose. Beta DGF means beta D glucofuranose. So here is the some simple abbreviation of a glucose. So this round head uh, means CHO group, and if there is OH, we can write a single line like that. OH group. We in this structure we uh, we didn't we do not mention the OH, that hydrogen position. Just mention the line for OH group. There is one OH, right side two OH, and the less tail position is CH2 OH group. So this is a general abbreviation. We can write acyclic form. We can write the glucose. This is the D glucose structure of D glucose. We can write it in this way also. So now come to the point. So this D glucose exists in cyclic form almost 99, more than 99%. So these are the glucopyranose form. Means when the 1 2 3 4 5, the oxygen OH group in carbon 5 react with this CHO group, then there is two anomer form. One is alpha anomer, one is beta anomer. So in D glucose, see, in D glucose, the bottommost chiral carbon OH is D in nature, mean right side. Then after cyclization, if the OH is right side, then it is called alpha anomer. If the OH is left side, then it is called beta anomer. So see here, 1 2, here is on OH group, here is on OH group, here is on OH, and this is on OH group react with the CHO. So remember that this is not any carbon or CH2. You can imagine that this is a CH2 group, but not, this is not a CH2 group. For drawing, proper drawing, we just draw like that. So this is a six member ring. 1, 2, 3, 4, 5, including oxygen. This oxygen is this oxygen. So six member ring. Here is also six member ring. So this is alpha anomer, this is beta anomer. These are known as alpha D glucopyranose. This is beta D glucopyranose. And we all know that in beta D glucopyranose, the OH group is in equatorial position, but in alpha D glucopyranose, the OH group, one OH group is in axial position. So beta D glucopyranose is more stable than the alpha D glucopyranose. That's why the percentage, the proportion of beta D glucopyranose is more in the in equilibrium concentration. Beta D glucopyranose is 64% and alpha D is 35.8%. So both total contain 9.8%, 88%. So D glucose also exists to Furanus form. Furanus means if five member ring is formed. If this OH, if 1, 2, 3, 4, if the OH group in carbon 4 is react with this CH2 group, then a five member ring is formed. Means this is one carbon, 2, 3, 3, 4, 5. This is a five member ring. So again I am telling that this is not any CH2 or carbon. For proper drawing, we just draw like that. So this is not, remember that this is not any carbon or CH2 group. So 1, 2, 3, 4, 5, five member ring. These are OH group. These are OH group. These are OH group. So this is known as alpha D glucopyranose, since OH group is right side. This is beta D glucopyranose. OH group is left side. So now come to the exact point to the question. So D-glucose reacted with excess acetone, what will be the product? So one point, always remember that theoretically we can say anything, but practically or laboratory, what we will find, normally we found that when a reactant, in this case this D-glucose is reactant, when a reactant is treated with any reagent, in this case reagent is in this case any second reactant, or you can say reagent is acetone. So the reactant, in this case glucose, try to follow that path, in which path the reagent is maximum used, means the reactant react with the reagent in such a way that maximum amount of reagent or used more and more reagent used by the way or by which path, then the reactant try to follow that path only. It means that when a reactant treated with any reagent, so the reactant try to follow a particular path, in which path maximum amount of reagent used up by the reagent. Maximum amount of reagent means maximum amount of reagent used up by this reactant. So now we all know that acetone. We all know acetone. Acetone is used for 1,2-diol blocking. So if there is many types of OH group, many types means 1, 2, 1, 3, 1, 4 positions, 1, 2, 1, 3 positions, then acetone react with only 1,2-diol. Obviously this 1,2-diol should be in cis manner. So acetone cannot react with 1,3-diol. So acetone is used for 1,2-diol. So we can say for 1,2-diol blocking we are used acetone. We all know that. We all know that the point that uh, acetone is used for 1,2-diol blocking. So now here is the main concept. So see, this two six member ring, that is alpha D glucopyranose and beta D glucopyranose. See, alpha D glucopyranose, this one, this two. 1,2 diol is present. There is no other 1,2 diol. 1,2, these are trans. This 1,2 diol is cis manner. This is a OH, this is a CH2 OH free, but these are 1, 2, 3, 1, 3 diol. In beta D glucopyranose, see, these OH and these OH are 1, 2 position, but these are trans position. These OH and these OH are 1, 2 diol, but in trans manner. This OH and this CH2 OH, free CH2 OH are cis, but still 1, 3 position. So in this anomer, alpha D glucopyranose anomer, there are one type of 1,2 diol present which are cis manner. Let's see the other anomeric mixture, furanose form. Pyranose means 6-member ring, furanose means 5-member ring. See this alpha D glucofuranose, see 1, 2. This 2 OH group means 1,2 diol in cis manner. This 1, 2. This 1,2 diol is trans manner. See, there are two OH group. One is this OH and another is this OH. So 1, 2. These two OH are 1, 2 position also in cis manner. So in this case, we found that there are two type of 1,2 diol which are cis in manner. Let's see the beta D glucofuranose form. Here 1,2 diol trans manner, 1,2 diol trans manner, 1,2 diol cis manner. Only one type of diol, that is cis manner. So among the 4 cyclic form, this beta D glucopyranose, there are no 1,2 diol in cis manner. So this will not react. This will not react with acetone. In this form, this anomer alpha D glucopyranose, only one type of 1,2 diol means this and this in cis manner. In beta D glucofuranose, in this anomer, only one type of 1,2 diol means 1, 2. These are 1,2 diol which are cis manner. But in the alpha D glucofuranose form, see here we found two type of 1,2 diol. Two type of 1,2 diol means this OH and this OH. One type of 1,2 diol which are cis manner. This OH and this OH. Second type of 1,2 diol which are in also cis manner. So now what I told a few minutes ago, that when a reactant treated with any reagent, the reactant try to follow that path in which path maximum amount of reagent can used. Maximum amount of reagent can be used by that path. The reactant follow that particular path. So since though glucose exists around 99.8% in this two form, and almost 0.002 or 0.01% exist in this two form, still among these four cyclic structure means among these four anomer, only alpha D glucofuranose can able to react with two equivalent of acetone. Means if glucose react with this form, then two equivalent means maximum amount of reagent means acetone are used. If this anomer react, then only one equivalent of acetone used, because there is present only one type of 1,2 diol in cis manner. Here also present only one type of 1,2 diol in cis manner. So since alpha D glucofuranose, there are present two type of 1,2 diol in cis manner. So this will react this will react with acetone, two equivalent of acetone. So among these four anomeric mixture, only alpha D glucofuranose, is able to react more, means maximum amount of acetone. This will not react because there is no 1,2-diol. This and this anomeric mix, these anomer react with only one equivalent of anomer, but if this anomer react, then two equivalent of acetone required. So I just mentioned that when any reactions, when we treat it with any reactant by some reagents, then the reactant follow or try to follow a particular path, in which path maximum amount of reagent is used. So if glucose react by this via this anomeric form, then in this case maximum amount means two equivalent of acetone will used or will be taken up by this form. But in this case, in these two cases, only one equivalent. In this case, no acetone is used up. So glucose, though percentage of this form is very low, still glucose transform into this form and react with two equivalent of acetone to form the corresponding bisketol. So I redraw the all structure. This is alpha D glucopyranose, beta D glucopyranose. These are the six member ring, and this is alpha D glucofuranose. This is beta D glucofuranose. So in alpha D glucofuranose, since there are two type of 1,2-diol in cis manner, this diol 1,2-diol cis manner, these OH 1 2, these are also in cis manner. So this form react with acetone to form bisketol. Among the four other options, there are no way to form a bisketol. This alpha D glucofuranose form monoketal, this beta D glucofuranose form monoketal, beta D glucopyranose cannot react with acetone because there is no 1,2-diol in cis manner. So now if we treat it with acetone, then this OH and this OH react with acetone, and this OH and this OH react with acetone. So 1 2 3 4, and this oxygen five member ring is there. Again I am telling that this is not a carbon or CH2 group. For just proper drawing, we are drawing like that. So this is a five member ring including oxygen 2 3 4 5, 1 2 3 4 5. So this is the reaction. So the 5 and 6 position, there are two 1,2-diol. So this 1,2-diol react with one equivalent of acetone, and there is another 1 and 2 position, there is another type of 1,2-diol which are cis manner. This diol also react with acetone to form a bisketol. So if we draw the structure like this, then this will be the product. So this two oxygen is in 1 2 position and cis manner, react with acetone to form like this, and also there are two OH 6 and 5 position. These are also 1,2-diol which are in cis manner. They also react with one equivalent of acetone. Means in these reactions, two equivalent of acetone is used. So only alpha D glucofuranose, only this form react with excess acetone to form the bisketol. There are no options for the other three anomeric mixtures. So among the three anomeric mixtures, two in two of them there are present only one type of 1,2-diol in cis manner, so they can form only monoketal. So so since since in this form there are two types of 1,2-diol in cis manner, so this form react with acetone to form a bisketal. So I hope you all understand what I am trying to say. So now the options are so A options there are six member ring, B option C there are also six member ring, so these are not correct. So B, if we see B, so C, these two OH react with acetone, and these two OH react with acetone. In D, in D, they in D option C, these OH and these OH, these trans OH react, and these are also 1,3 position, not 1 2, 1 2 3. These two OH are 1 3 position, so this is not the correct. So the correct option is B. See also the answer key, question number 7, and the correct option is B. So I hope you all understood the concept. According to me, it was the most conceptual questions ever asked in any competitive exam. So that's all for today. Yeah, I wanted to mention that there are many reactions of glucose. So regarding this structure, so by blocking, so I am just mentioning that acetone is used for blocking onto-diol. So there are many reactions in glucose. So first we have to block this one two this 4 hydroxyl group. Then there are many reactions after blocking this. So in our upcoming video, I will show you the all type of reactions after blocking this diol. What different types of reactions we will perform on this structure, on this bisketal. So stay tuned for more. Thank you for watching. Stay safe, stay healthy.